Alright, Algebra 2, this is section 5.4 notes, the second part of the notes. What I'm going to do now with factoring, and I hope you notice that this has a 3, which is different from the other problems we were working on in the first part of the lesson. Does this have a GCF? Clearly it does not have a GCF. There's nothing in common to all the terms. But that is the first question I would continue to ask myself, so don't forget about that. What I'm going to do right now looks like a magic trick, so I want you to kind of hold on to your hat and follow along. The first thing will look kind of weird. I'm going to actually take this 3 and multiply it by the 5. Now the reason I'm doing this is because I don't want to have to guess and check what the factors of 3x squared are. You know, a lot of these other problems we did, we had x and x. Well, 3x squared wouldn't be that hard to figure out, but as soon as you start getting into 4x squared and 6x squared and 8x squared, then it becomes a lot more complicated. So in order to alleviate that, I just have a nice method to do this. So 3 times 5, and it looks like I removed the 3 and I moved it down to the end. Now what I'm going to do next is I'm going to factor these, but I'm going to leave a little bit of room. So in other words, this is x and x, but you'll notice that I left a little bit of room in front of the x. There's a reason for that, because the next part of the magic trick will involve that. But I'm going to factor it the normal way. I need factors of 15 that add up to negative 16. Yes, that means both of them must be minuses, and the factors of 15 would be 15 and 1. Now here's where the magic comes back into play. I'm going to take that 3 that we took out and I'm putting it in front of both of the x's. Now, I'm going to go through each one of these parentheses separately and ask myself this question: is there a GCF? Is there a greatest common factor? So if I'll start over here, the 3x minus 1, is there a greatest common factor? If there is, I'm going to pull it out and throw it away because I don't need it. But there isn't one, so I'm going to leave it alone. However, over here I notice that both of them have a 3, so I'm going to pull that out and throw it away. This is the factorization of 3x squared minus 16x plus 5. I didn't have to do a lot of guessing. This method works every time. So we're going to practice just a couple more of these so you can get the hang of it. So I take the 2 and multiply it times the 12. Well, first of all, I look for a GCF, and I clearly do not see a GCF. Okay, so then I can go ahead with this process. Putting the 2 with the 12, giving me a 24 down there. Put your x's in, leave a little bit of room in front. Factors of 24 that add up to 11. That would be plus 3 and plus 8. Put the 2's back in front. Now I can look for a GCF. Do I see a GCF inside here? Yes, I do. Pull it out, throw it away. See a GCF there? Nope. And there's my factorization. Works really well. Okay, I want you to try this one on your own. So factor this one on your own and show me in class. Alright, next. Is there a greatest common factor? That's always what I want to ask myself. I do not see a greatest common factor. So this is more practice with the magic trick that we just talked about. So I want you to try this one. I also want you to try this one. Also no GCF. And this one. So far you got 4 factoring questions to do that involve this magic trick. Oh, next. Alright, now, the factoring on this one. Yes, we can use the magic trick on this because there's nothing in common between 9, 42, and 49. I can use the magic trick on it, but I want you to notice something here. This is a perfect square. Right? This is 3x times 3x. I also want you to notice something here. This is a perfect square, 7 times 7. So with that in mind, this is 3x and 3x, 7 and 7. Because they have to add up to a negative number, they both have to be minuses. Just double check. Negative 21x is in the middle. Negative 21x is on the outside. Those add up to negative 42x. That's good. So, in other words, another way to write this one is 3x minus 7 quantity squared. And yes, you need to be able to do that. You need to be able to write it in that format with the exponent. So when you see them and they are perfect squares on the ends, then that is going to make your life a lot easier, because take the square root, take the square root, and they have to add up to a positive number, so they both have to be pluses. Alright, so here's one for you to try. The last situation is, once again, perfect square, perfect square. You'll notice that the middle term is missing. That's because it's 0. So in other words, yes, this is x and x, 8 and 8. But I need factors of 64 whose difference equals 0. So how do I do that? Well, if one of these is positive and one of these is negative, then I would get a difference of 0, right? Negative 8x, positive 8x. And their difference would be 0. And no, I can't write that as something squared, because obviously these two things are not the same. Alright, here's one like that. But is there a GCF that you can worry about? Yes, there is. So pull out the GCF first before you break this apart into its pieces. Okay? So do that for me first, and I'll look at that example tomorrow.